In the last example, we measured the position or the vertical position of a spring versus time, right? Now we're going to look at measuring the horizontal position of an object versus time, okay? We're still going to use the y-axis as our position, and we're still going to use the x-axis as the time. In this example, they talk about a pendulum. Can't talk. Pendulum. All right, so let's say that we have a pendulum. It's going to swing something like this, okay? It's going to go like this, back and forth, back and forth. All right, let me draw it a little bit better because I don't have it quite drawn good enough. All right, this will be what we call its equilibrium position. And it'll swing something like this. Okay, it goes back and forth, okay? If it's resting, then it's right here. The block is right here, okay? Now, what do they say for this example? They say, suppose you grab this and you pull it to a spot 4 inches to the left of its resting area. So what are they saying right there? They're saying that from here to here, we're at 4 inches, okay? And what's going to happen? If I release that, it's going to swing back over here. Now, assuming that there's no forces slowing it down or anything, it's going to go all the way to 4 inches this way, right? Now, what I like to do is I like to call this a positive 4 inches in the right direction and a negative 4 inches in the left direction. Okay? So what happens? We grab this block that was at rest, we pull it this way, we let it go, right? And then the moment we let it go, we say that that's time 0 seconds. So time 0 seconds is at negative 4. And then what happens? It swings back and forth and back and forth, okay? So I want to look at modeling the position versus the time, okay? So let me think of a graph of this thing. Let me think of a graph. If this is going to be my position axis, and I'm going to go ahead and call it D here. Where does my position oscillate between? In other words, layman's terms, where or what is the minimum position it takes on? What is the maximum position it takes on? So the minimum position is going to be negative 4. The maximum position is going to be 4, right? And they say, okay, let's pull it back to this negative 4 position and then start counting the instant we release. So the instant we release, that'll be like this t-axis or this time axis as 0. So the time will be at 0, and what position will it be at? Negative 4. So at my time being 0, I'm at the point negative 4. So that gives me the order pair 0, comma, negative 4. Now remember, this order pair is time in seconds and then position in inches. Draw better parentheses than that. Alright, so we have the point 0, negative 4. Now, this problem talks about it goes back and forth in a matter of what? 2 seconds, it says, right? Because it talks about the pendulum makes one complete back and forth cycle at 2 seconds. So 2 seconds is back to where it started. So if I go out here to my time of 2 seconds, where's my position again? At negative 4. So I can plot that. At 2 seconds, my position is down here at negative 4. So that's 2, negative 4. So where would it be at 1 second then? If it takes 2 seconds to go back and forth, at 1 second, wouldn't it be over here? So what's my position it would be at? 4. So at 1 second, I'm up here at 4. 1, comma 4. How about at a half of a second where I'm at? Well, if it takes 1 second to get to here, in a half a second it would be right here at where? At 0. So at a half a second I'm at 0. How about at 1.5 seconds? Okay, we said from here to here is a half a second. Then we're at 1 second. Then if we go back, we're at 1.5 seconds. We're back at 0. So what if I connect these points with a nice little curve? What do I get? Get a curve that looks like that, right? And what does that look like? That looks like the cosine function reflected across the what? Across the x-axis. So let's look at each part here. They want us to determine what is the period of motion. What is the period? What is the period? Well, how long does it take to do one complete cycle for the cosine function? Well, this says it takes what? From 0 to what? 2 or 2 seconds. So the period's 2 seconds. Actually, you didn't even need a graph for that. You could have looked at the wording in the problem. It does one complete cycle in 2 seconds. Hence, the period be 2 seconds. How about part B? What is the frequency? What is the frequency? Actually, let me start writing with a different color. What is the frequency? Isn't the frequency 1 over, or the reciprocal of, the period? So 2 is 2 over 1. So if we reciprocate that, we get 1 over 2. And what's my unit? They told me at the beginning the unit is hertz for the frequency. Part C. What is the amplitude? What is the amplitude? Well, look at your graph. Where do you oscillate between? -4 and 4. So your amplitude would be what? 4. But we need units here. What are my units of this? What is this? This is the what? Position, right? What is the position measured in? Inches. Okay. Let's look at D. Write a function and model its displacement D in inches and the bob is a function of time in seconds. Alright, I'm going to have to erase some of this so I can write. Alright, part D. Write a function that models the horizontal distance basically, okay? So they told us to use either this on the previous page of notes. They told us to use D is equal to what? A times the sine of omega t, or D is equal to a cosine of omega t, right? Well, what does this fit best? Not fits the cosine function best, right? So I'm going to use D is equal to a cosine of omega t. Don't let that omega scare you. That's basically what we call B before. Alright, so D is equal to A. What would A be in this case? The amplitude? What did we talk about the amplitude was? 4? But don't forget, this is the cosine function reflected across what? The x-axis, so I need a -4 right there. Times the cosine of omega times t. So let's find the omega here. Well, my period is equal to 2 pi over b. Whenever we learned this the first time, right? What was b? Just a number that was being multiplied by t, right? Well, in this case, they're saying omega, so I just use omega. What is my period? We said earlier the period was what? 2 or 2 seconds. It's equal to 2 pi over omega. Multiply both sides by omega, so 2 omega is equal to 2 pi. Then we can divide by 2, and omega is what? Pi. So for omega here, I'm going to put in pi. And there is my function they wanted to model. This thing right here. Alright, let's see what else we have. We have a part E that says find the position and direction of movement of the bob at t is equal to 1.25 seconds. Alright, so I want to find the position and movement at 1.25 seconds. Let's think about this. Y'all told me at 1 second it's over here, right? Y'all told me at 1.5 seconds it's right here, right? So 1.25 seconds, wouldn't that be between where it's at 1 second and where it's at 1.5 seconds? So it'll be somewhere like right here, right? So the position's going to be to the right of the equilibrium point here. But where exactly is it going to be? How many inches over here is it going to be to the right? Well, let's find it. All right, so we said 1.25 seconds, right? And this is part E. T is equal to 1.25 seconds. All right, so what I'm going to do is I'm going to use this function I came up with to find my displacement, to find out where I'm at. D is equal to -4 times the cosine of pi times 1.25. Sorry about that. Some electronic device in here made a noise, and I thought that was my camera kicking off, so I had to see if it was still recording. Alright, so D is equal to -4 times the cosine of pi times, what's 1.25? Isn't that 1.5? I'm sorry, 1.25, not 1.5. So D will equal to -4 times the cosine of, -4 times the cosine of 1 1/4 times pi. I could call that if I wanted to. You can call it 5/4 pi. It doesn't really matter. Alright, let's try to find this now. 1 1/4 pi. Where's my cosine function at? Well, time to think about your unit circle again, okay? If you think about your unit circle, here's your unit circle. 1 pi is here. 1/4 more of a pi is right there. So that's at a reference angle of pi over 4, right? So if I'm right there at 1 1/4 pi, what's my ordered pair? Negative square root of 2 over 2, comma, negative square root of 2 over 2. And remember, these run cosine, sine. So what is my cosine of 1 1/4 pi? 1 1/4 pi, what's my cosine? Negative square root of 2 over 2. So this is equal to -4 times negative square root of 2 over 2, because this whole thing turns into that. So what does that give me? Negative times a negative is a positive. 2 square roots of 2, right? Now, what is this? What is my units for this? This is my displacement, 2 square roots of 2. That's how far I'm displaced over here. Well, what's it measured in? Inches, right? So, what is it asking me for exactly in this problem? It's asking me for find the position and direction of movement of the bob at 1.25 seconds. So I'm going to say the position is going to be 2 square roots of 2 inches. So it's going to be somewhere over here. 2 square roots of 2 inches. And what do they want to know? The movement of the bob. Or I could say 2 square root of 2 inches to the right of the equilibrium point. Because remember, that's the equilibrium point. Right of equilibrium point. just abbreviate there so there's a amount of room on this little board. What's the movement? Remember we said 1 second it's going like that, right? And 1 second it's going to be here. 1.5 is going to be there. So 1 1/4 is going to go bam, and then it's going to be moving this way, right? So it's going to be moving which way? To the left. Movement is going to be to the left. And let me go ahead and box all this in. Now, I want to say Alex is going to have you round this number right here, so you'll just put that in your calculator and round it to whatever they say. Good luck with the homework.